Thank you very much to the Albertus Institute and Dr. Mark Harris, all those who contributed to this conference. Actually, the title of my talk was originally going to be Cosmology and Being, but probably I thought afterwards that might be a little bit too pretentious. So let's make it slightly more modest. Cosmology, a clarification of the philosophical questions. I see there's a screen there, so I'll try to follow my own talk. Okay, is this working? Right, the warning of Hamlet, Act 1, Scene 5. Anyone can guess what this is? Okay, all right. There are more things in heaven and earth, Horatio, than are dreamt of in your philosophy. That's really the bottom line of what I want to talk about. We have certain models that we keep building of the world, and some of those models become somewhat ingrained, so part of the way we think, that we forget they're models at all. We think that is the world, and that's the big problem. It's having a huge impact, or is having a kind of, it's almost like creating a veil over our ability to make progress in certain fields, including, I would say, cosmology itself. Now, modern books on physics usually present, I see this distorted my talk slightly, this computer, never mind, usually present a limited kind of cosmology, generally in terms of laws of matter in motion in the space-time box, albeit a stretchable box after Einstein. And what I put to you is if cosmology, the etymology of the word being, so the definition of the word being the science or theory of the universe as an ordered whole, if we take that seriously, and the universe is all that is created, then a cosmology that is not limited or defective has to take account of what it is to be, not to be, and coming to be, with a very broad understanding of the term being. A very broad understanding of the term being. And that's where the philosophy comes in. Now, even some of our leading scientists today have little or no training in philosophy. About 2 years ago, I had the privilege of taking part in a roundtable discussion with the Director General of CERN and some of the leading scientists at CERN. It lasted 3 days, and was interesting, the Director General spent a long time listening. And what was also interesting is how basic philosophical questions kept coming up, like, what is truth? Seriously, we debated that for 2 or 3 hours. What is truth? What is knowledge? What I was aware of coming away from that meeting is how little training our best scientists have in philosophical questions. It is not as if questions of truth are new for human beings. We've been talking about these things for 23 centuries or more. But the kind of training we're now getting in natural sciences means that although we can calculate quantum electrodynamics, many people who are very highly trained mathematically do not have the experience of engaging with philosophy. And I think that may be at the root of some difficulties in contemporary science. And of course, it's also true for theology. In fact, when Oxford University started, for example, you weren't allowed to study theology until you had first studied philosophy and astronomy and various other disciplines before you were even allowed to touch the theology books, because you needed to have this training in philosophy. I think we all need Philosophy 101, as they say in the United States. Now, it's always good to have a foil. By the way, those of you starting out in graduate studies, get a foil, get something to wrestle with. And I've chosen this statement in a popular book, The Grand Design, by Hawking and Lodinow. I'm not quite sure how to pronounce his name, so apologies. If someone can correct me, I'll be grateful. I'll just read it to you. Traditionally, these are questions he's referring to about cosmology. These are questions for philosophy, but philosophy is dead. That's quite a strong statement. We will describe how M-theory may offer answers to the questions of creation. M-theory predicts that a great many universes were created out of nothing. Multiple universes arise naturally from physical law. Page 1 and page 8 of The Grand Design. Now, this is the kind of book that I would have been fascinated by as a teenager, and a lot of our teenagers are reading these books. And, you know, on page 1, philosophy is dead, so don't look at it. Eh? That's what Stephen Hawking is telling you. This is quite serious stuff, right? So what I want to do is ask the question, is philosophy dead? Its role usurped by science? Can M-theory or any theory answer questions of creation? Can even a single universe, let's make a more modest claim, a single universe arise from physical law? And how should we explore the question of creation? So briefly, I want to go back a little bit, because modern physics is changed certain ways of looking at the world from ancient physics. But I want to look a bit at ancient physics to understand those changes better. I want to look then at the implications of science for philosophy, responding to the Hawking challenge. And then, as I used to work in business as well, I want to look at added value. What does faith do, if anything, for cosmology? Okay, so personal background. I worked at an experiment which was the biggest in the world at the time, but nothing compared to Professor Buss's work on the Atlas experiment these days. But back in the late 1980s and 90s, I was working at the Large Electron-Positron Collider, helping the muon build and test the muon chambers built at Oxford. And that was a page from my PhD thesis. All completely superseded now, but rather fun. Okay. But I have to say, as a physicist, what did intrigue me was not so much the technical details of the particle experiments, but seeing beauty in the basement of reality. And just at the time I was working at CERN, I think there's a lot of interest in fractals, in the Mandelbrot set, for example. These things go on forever. They never repeat. I'm not sure what philosophical lessons to draw, but I've always got a sense of awe that there's beauty down in the basement of reality. So philosophy 101. The question why. Oh. I've jumped ahead a little bit. Okay. Right. So the question was, so the point I'm going to make, children ask the question why. And when I was 10 years old, I remember going to France, to Lourdes actually, with my family. And there was a French boy running around this campsite saying, "Pourquoi, maman, pourquoi?" really annoying his mother. So obviously they ask it in other languages as well. It's natural for children to ask the question why. And the first word to any answer to the question why is because, which has two parts. Sorry? What are the two parts of because? Being cause. The cause of the being of a thing. So philosophers ask the question why. Children ask the question why. Of course, as they grow up, they tend to ask how and then how much. And our challenge is to get them asking why questions again. And any question why generates some kind of answer which refers to the causes of the being of a thing. And so if you're going to do philosophy, you're going to look at causes. This is a pretty dead battery, sorry. Okay, so any ordered or valued knowledge involves understanding causes. There's a lot of trivial knowledge you can get. Thomas Aquinas gives an example, how many stones are there in a river? That's trivial knowledge. That's you know, presumably there's some kind of answer, but it's a pretty useless fact. But knowledge that's valued and ordered involves understanding causes. Roughly speaking, the principles, or that which brings about the being of a thing. And the more philosophical and valued knowledge deals with first causes and principles. And this is a statement actually made at the beginning of the Metaphysics of Aristotle. The most exact of the sciences are those that deal most with first principles, for those which involve fewer principles are more exact than those which involve additional principles. Okay, let's turn that into a heuristic. So roughly speaking, the way that we look at the world, or the way that we've looked at the world in the Western intellectual tradition particularly, is an ever smaller number of ever more powerful causes. And to some extent, the passage between knowledge and wisdom is a passage between many particular things which are easy to know about, and a small number of universal causes that are hard to discover. And this same heuristic has shaped all kinds of human endeavors. For example, material reality. You can start with a very large number of compounds, the very much small number of elements. That's a huge achievement to know that, to discover that a very small number of elements are responsible for these millions of chemical compounds. And of course, the work of particle physics tries to find the smaller units of which these are based. Now, this is a heuristic. Every now and again, the funnel opens up sometimes, and it shrinks down. But we're happy, we generally like to see ever small number of ever more powerful causes. But it's not just restricted to material reality. It's the same with ourselves. So particular human actions, washing, waking up, having lunch with friends, going to college. Why do we do these things? What are we looking after? Most answers to that question to do with the flourishing of the body, the society, and the mind. And why do we do those things? Why do we want body, mind, and society to flourish? We spend a lot of time and money on these things. Well, yes. Actually, you get a clue from this going to supermarkets. So I sometimes start philosophy by advising students to look at the packaging in supermarkets. So I once found a packet of biscuits offering me snacking nirvana. I once found a yogurt called Bliss and a cheese called Heaven. I said to the lady selling the cheese, we're obviously in the same business, but you're making more money than I am, right? But the point is that, by the way, the advertising, I don't know if you know the history of this, advertising started with the nephew of Sigmund Freud, a man called Bernays. And he understood that all human beings seek happiness and are dissatisfied with what they have. So again, you get the same sort of narrowing funnel. Now, some people are puzzled by what philosophy studies. Well, actually, it studies everything. Everything that is said to be, but in terms of the narrow end of the funnel. So everything, I mean, chemicals, music, winemaking, ideas, grammar, everything at the broad end of the funnel. But the first causes and principles are where philosophy has its distinctive discipline. Now, I put it to you, that's one reason why God doesn't go away. And part of the reason why is we get an ever small number of ever more powerful causes, then naturally the next question to ask is what's at the end of the funnel? And that is why a lot of people who call themselves atheists are actually not disputing the existence of a first cause, which is the philosophical definition of God, but they are actually disputing a personal first cause. They're actually trying to substitute a personal first cause with something else that purports to do the same job. The real battle, you might say, is not over whether God is, but what God is. There is one exception to this, and as we're in Edinburgh, and I've just passed the statue of David Hume, there is, of course, Hume took the much more radical path and understood that if you really want to get rid of God, you've got to attack the notion of causation. And, it's, of course, if you follow that through to its logical conclusion, you'll have to dispense with a lot of other things as well, including, I would say, a lot of science. But anyway, that's the other route for, if you like, opposing theism. But most people who oppose theism end up offering a substitute to the first cause. And you may think that's a bit fanciful, but let me give you an example. So, millions of flowers on the earth tell us his love. Blue waves of the ocean sing of his work. He's a creator of happiness. Now, where would you expect to see these words, normally speaking? Sorry? In a dubious hymn. Yes, exactly. Yes. Not a very well-written hymn. Okay, that's right. As I'm sure some of you would have known, it is a patriotic song of North Korea. And the reason I show that is North Korea is an interesting example of a society where all belief in a transcendent God is outlawed. Outlawed. I mean, as a Catholic priest, I could never work in North Korea at the moment. We have only one Catholic church in the capital. We can't appoint a priest there. You can't worship publicly. You can't worship publicly as a Christian in North Korea. But what's happened to religion? I mean, basically, the divine attributes have been shifted to a God substitute. In this case, Kim Jong-il. This is slightly out of date, of course. It's now his son, the grandson of God. Kim Jong-un. Okay. So I sometimes warn people, by the way, if you abolish a belief in a transcendent God, you create a job vacancy. Okay. So change, constancy, and Aristotelian physics. So the business of a wise person is to order. That, by the way, is a phrase that comes from the beginning of Aquinas' commentary on a Nicomachean ethics. The business of a wise person is to order. But understanding the order involved in change is something of a challenge, because change involves something which changes and also something which doesn't. Some kind of constant against which the change can be said to be and to be known. This is one reason, by the way, for the doctrine of divine simplicity, a doctrine that God doesn't change. Because you would need the change to be with reference to something more fundamental than God, which is a contradiction of terms. So change in the cosmos requires something which can be said, requires something changing, but also something which doesn't change. And one of the major philosophical questions of all time, and the answers to which are the root of different divergent schools of philosophy, is what are the principles that provide this constancy? What are the principles that provide this constancy? So order and change. So that the hands of a clock, you also need the clock face. It's an interesting question whether if you just had the hand of a clock and nothing else in your cosmos, whether the clock could ever be said to move. I don't think so. So the three main schools of thought, and these, by the way, are constantly resurrected in different stages of history, in modern terms as well. The three main schools of thought. The one associated with Parmenides, this is a very crude way of putting it, but nothing changes. And perhaps a modern way of thinking about this is that although on a cine film, or you might see the different frames of a film, you might see a film where the characters appear to move. In reality, the frames are all static. And some people think of the universe as like that, like a 4D box universe where time is an illusion. And then you have on the opposite side of the arena, you might see the Heracliton. Heraclitus was famous for saying, you can't step into the same river twice. And his pupil, Cratylus, said, you can't step into the same river once. But everything changes, perpetual flow, processes, process theology, all that fits that school. But most philosophers fit in a bit of a mixture. Some things change and others do not. But the choice influences a great deal how they approach the cosmos. So roughly speaking, here are a few schools of thought. Plato with forms and ideas. Aristotle with substances. Now, the change you get in modern science is to space and time. Now, Einstein shifted that again, but we've subverted his insight. Einstein thought of light as more fundamental than space and time. Then we've mathematicized it, and we've subverted his insight. With Christian theology, we've taken mixtures of different schools at different times. But one unique principle emerging from Christian theology is the person. What we borrowed from other schools, particularly the Aristotelian school. Substance. So one of the challenges of first principles is you can't define them very easily with things that are more basic. So you often have to have several definitions to give you an understanding of the term, and that's true for substance. There are about 6 or 7 definitions in Aristotle's work, but there are a couple that are particularly stand out. That which is called a substance most strictly, primarily, and most of all is that which is neither said of a subject nor in a subject, the individual man or the individual horse. And it's interesting he uses biological prototypes for substances in this example. or that which remaining numerically one and the same is capable of emitting contrary qualities. So now, where he's getting this from is the study of biology. In fact, Aristotle invented biology. There was a wonderful documentary on BBC 4 about 2 years ago called Aristotle's Lagoon. If you ever get a chance to watch it, I do recommend it. But it describes something of his remarkable experiments with living things and learning about living things. He was fascinated in a living thing that all the matter is organized towards the flourishing of the living thing. And living things can undergo all kinds of changes and yet remain the same beings in some sense throughout. We undergo extraordinary changes through our lives, and yet we also have this sense of identity throughout our lives as well. So Aristotle took this as a kind of first principle, an organizing principle for other kinds of changes. And an example of this, metaphysics 4.2. So too, there are many senses in which a thing is said to be, but they all refer to one starting point. Some things said to be because they're substances, or affections of substance, or processes towards substance, or privations of substance, or generative of substance, or relatives of substance, or negations of these things, or substance itself, etc. So he's organizing his account of change around the principle of substance. And he sees different kinds of accidents as having being associated with substance, and these being changeable, while the substance, in this case Socrates, remains in some sense the same. The deeper implications of this model are not actually often widely appreciated. One of them being that being in the world only fits together in certain ways. And it's one of the things that may, by the way, undermine the ordering of grammar. I mean, children often are able to acquire grammar more easily than formal rules would suggest. And part of the reason is perhaps they're picking up the ordering of the world suggested by that nature only fits together in certain ways. And this is in contrast to nominalism, where, in a sense, it's only that various objects labeled by the same term have nothing in common but their name. A lot of the way that modern logic works tends to be nominalistic. So some of these distinctions are often lost. Now, the origin of the word physics is the Greek word physis, which often translates as nature, but refers more precisely to the principle of immanent self-perfecting activity, especially in living things. What each thing is when fully developed, we call its nature, whether we're speaking of a horse, a man, or a family. So actually, Aristotle thinks natures are obvious. This is an interesting contrast to Newton, who talked about natures as occult things. Now, as used by Aristotle, what was studied under physics, he actually wrote this huge book, which we translate as physics, would probably best be described as a kind of biologically inspired metaphysics. But the root metaphor for understanding the world is the living organism. And from a Catholic perspective, this has had a huge impact on theology. Most famously, every Sunday Mass, where the Creed is recited, we're using a term borrowed from this philosophy, homoousios, of the same substance of the Father and the Son. And of course, Aristotle's four causes, he uses living things as examples of these things, and he distinguishes different kinds of causes operating in the world by how they contribute to the being or the flourishing of substances, and also artifacts are slightly different for artifacts. Okay. And just also for a bit of background knowledge, these three concepts are very closely related in Aristotle and also Thomas Aquinas. Nature, determined by the fully developed form of a thing, the end, the final form of a being, and the good, what the being seeks to become by nature. Okay, so just a few interim definitions at this point. So philosophy, the love of wisdom, deals with first causes and principles. Nature, what each thing is when fully developed, whether speaking of a man, a horse, or a family. And substance, that which is called substance most strictly, primarily, and most of all, is that which is neither said of a subject nor in a subject, the individual man or the individual horse. So that's a bit of background for Aristotelian physics. Now, all that changes with the rise of modern science. Now, this change is prefigured in all kinds of other developments in the Western intellectual tradition, one of which being the development of perspective in art. A lot of 14th, 15th century art, you get the sizes of the figures determined by how holy they are. So it's interesting, if you look at Quarton's Coronation of the Virgin, you see these little tiny figures on earth below, and these huge images of the saints above, dominated by the Trinity and the Blessed Virgin Mary in the center. But you see here, with linear perspective, the size of the images is, the size of the figures is determined by distance from the observer. But what I want you to be aware of here is how this is beginning to affect the way we're thinking about the world as things moving in a kind of geometric box. And with the Cartesian geometric revolution, this process is taken a step further and put on a theoretical basis. So in Descartes' Discourse on Method, he introduces the idea of specifying a point or object on a surface using two intersecting axes as measuring guides. Now think of the implications of that today. Cartesian graphs, all kinds of coordinate systems. Modern science is unthinkable without all of these things. It's given us tremendous power in terms of our ability to explore the physical world, but it may also be affecting, and in some ways limiting, the way we're thinking about the physical world. And we start off from a young age, children imposing or forming these ideas in the minds of school children. Now, what's not often appreciated is for Descartes, extension in length, breadth, and depth constitutes the nature of corporeal substance. So the extensions of a thing are not just some properties, but the principal properties or essence of the thing. And these Cartesian graphs carry metaphysical baggage of which people are often unaware. Now, with Galileo and with Newton, you get this process applied still further and really giving birth to what we call modern science. And Newton inaugurated the modern study of gravitation and the laws of motion. He neither discovered nor explained the causes of gravitation. And in fact, he was a bit sensitive about this point. So he couldn't really actually explain, offer a cause for action at a distance. And he said, I do not feign hypotheses about this. But he actually solved a different problem. What he did instead was to offer a mathematical description of how planetary positions, modeled as point masses, are described and change over time with respect to a hypothetical and immutable absolute space and time. For this worldview, space and time are the new immutable first principles against which change occurs. So whereas Aristotle, it's substance with being organized around substance, now it's space and time against which change happens. And so obviously this is the world we've grown up with. It's part of the air we breathe. Basically things moving in a space-time box, bumping into each other, coalescing, interacting in various ways. And this was an extraordinary achievement in certain ways. So having modeled each planet as a point mass relative to absolute space and time, in a state of mutual gravitational attraction with the sun alone, the two-body assumption, Newton was able to describe the present orbits and predict their positions indefinitely into the future using calculus. And that's still true today. We know where Jupiter will be in 1,000 years' time. It's an amazing achievement. We're able to launch a probe and reach a comet and land a probe on a comet. That's an extraordinary achievement. We were also able to make discoveries of things that were hidden, that were actually causing perturbations in our predictions. So the most famous example was the discovery of Neptune. The planetary orbits are perturbed, and this led to a prediction that there was another planet we hadn't yet discovered, discovered in 1846, which was Neptune. Now, this was so successful that it helped to promote a radical change from an organic Aristotelian view of the world to a mechanistic view of the world, which still constitutes the dominant root metaphor underpinning our thinking about the cosmos. Obviously, Newton's laws of motion, I learned them at the age of 13 or 14. Years later, I began to realize how subversive they are, because there are several things here that just wouldn't fit in to the understanding of causation in the ancient world. Now, this caused a shift in all kinds of different aspects of philosophy and the way we approach the world. So the study of the natural world shifted from the investigation of natures and causes to laws governing phenomenical representations, under which the property of one thing, measured under rigorous experimental conditions, could be compared to the same property of any other thing measured under similar conditions. And we have an ever-expanding set of conventional representations, such as second, kilogram, meter, specific heat capacity, charge, capacitance, and so on, the units of which represent an implicit ratio by which an object can be characterized by respect to some conventional standard. So a simple way of thinking about this is if you have a set of bathroom scales and you put a dog on the scales or a sack of potato on the scales will not distinguish between whether it's a dog or a sack of potatoes. The only thing the scale will measure is the force exerted on the object due to gravity. And this is the way we do a great many things in science. We look at how things will how things will respond under experimental conditions. And most of these conventional representations ultimately link back to space and time. Space and time are the absolutes in the background of all of these things. So, for example, famous example, it's one of the last of the old-style artifacts for these units, but it's the standard kilogram. The kilogram, it is actually an object, a physical object in a French laboratory. To say that a mass is 1 kilogram is to say that an object will accelerate with respect to space and time at the same rate as the standard kilogram if subjected to the same force. It's an implicit ratio. It's fine if we remember we're doing this. The problem is if we forget we're doing this and it becomes all there is to know. So science, science, one modern definition. By the way, if you look at the Oxford English Dictionary of Science, you'll see about 14 or 15 different definitions. Very difficult word to define. But here's part of one of them. A branch of study that deals with a connected body of demonstrated truths or observed facts, systematically classified and more or less comprehended by general laws. There's this idea of a law. And by law is a complicated definition. By law is intended, in modern natural sciences, an assertion of a general type normally expressed under mathematical form, intended to define and explain the behavior of a physical system in accordance with experimental measurements pertaining to situations of the same type. Sorry, it's so long. But you see, it's looking at the quantitative phenomena associated with an object under experimental conditions. It's not so good at saying what a thing is. And it's interesting, some recent examples of this, that people think that the limitations of science are just with big questions like God and the soul, right? But actually, there are actually rather simpler questions where science has limitations. Is Pluto a planet? Is Pluto a planet? This was a big problem for the International Astronomical Union about 10 years ago. And they all had to become amateur Aristotelian philosophers for a few years as they debated this. I mean, literally, they're doing the genus, species diagrams. It's got to be bigger enough to be in a sphere and orbit the sun and clear its orbit. They actually had to go through a process that Aristotle would have recognized, because you don't get answers to that kind of question out of laws of science alone, because they don't deal with essences. They deal with how things respond under experimental conditions. Okay, implications of modern science for philosophy. All that background, which may be familiar to some of you, but it's worth going over it again, because it has led to certain assumptions about the way we look at the world that we tend to forget our assumptions. One of the geometric representation of the world, objects moving against an absolute space-time background. And this has been symbiotic with applications of geometry in science, technology, art, and architecture. We live actually in a society that's very Cartesian. Everywhere you look, there's 90-degree angles in this room. Now, a philosopher on whom this revolution had a great impact was Kant, who has in turn influenced many theologians, I'm afraid. Actually, I have a bit of a gripe about this, so personal gripe time. But it's interesting, a lot of philosophers that love Kant, and Kant's view of science became outdated about 1850. But they love him so much, they still say, well, that's okay, we're going to carry on using it. Because absolute space and time, that's by about 1850 had begun to be questioned. But nevertheless, it's such a powerful sort of unified way of looking at the world that it carries on almost by inertia. So prioritization of measurement. It's the gold standard. The scientific revolution, sorry, I know it's a slightly outdated term, but sorry. Anyway, scientific revolution lent prestige to precise quantitative measurements as the gold standard of epistemological value. Now, so I'm taking interest in what's going on in experimental psychology today, and experimental psychologists take a lot of pain and trouble to turn what is intuitively obvious into some kind of quantitative measurement. So it's not enough to say babies recognize their mothers, right, within minutes of being born, and they can pick out faces within minutes of being born. That's amazing. Never seen a face before. But you actually also have to add a measurement to that, like how many times the infant smiles within a certain number of minutes on average with a stopwatch. Then it becomes knowledge that you can actually publish in a journal. We all have to go through this process, and it's good discipline and so on, but there is a slight absurdity to some of it. Okay? The ambiguity of species, natures, essences, and matter. All these terms have been, in some ways, denatured or denuded of value, including matter, incidentally. And I mentioned, the problem of defining what a thing is. Also, microentities. What is a quark? All these things are. There's a big debate about whether they could be thought of as real, whatever that means, or merely as convenient entities for the construction of useful models. And the meaning of matter itself is left quite ambiguous. The eclipse of teleology has a huge impact on philosophy. You see, go on a bit. So if you take the initial state of a Newtonian system, like a planet in a circular orbit, you reverse its time, you flip its spatial coordinates, you end up with what you started with. And we say that Newton's laws of motion are time symmetric. There are some weird exceptions to that. Entropy is one weird exception. It gives us an arrow of time. There's also something really weird. Maybe, I don't know, Professor Bussey may be able to shed more light on this later. The neutral kaon system in particle physics is, for some reason, doesn't have time invariance. Weird. But anyway, but a lot of the way we think about the world, time is treated like space. There's a wonderful book called The Trouble with Physics by Lee Smolin, who's a theoretical physicist. It was generally interpreted as being an attack on string theory. But actually, it's really someone thinking hard about what physics is and where perhaps there are certain blind spots in physics. And there's one graph I remember in this book, which is space and time. And it just shows space on one axis and time on the other. And he says, is this a smoking gun? Is this where we're going wrong? Can we represent time without turning it into space? That's what we do in Newtonian science. And you see, if time is just like space, does it exist at all? And if time is like space, and you haven't got a genuine telos or end of mechanical systems, then where does goodness come from? So Newton had a huge effect on ethics, because if you've got rid of teleology, if you've got rid of a telos of a system, a natural end of the system, then where do you get notions of good and evil from? Actually, there are only three bases, as far as I know, for how you can then ground ethics. Either God commands it, that could be very misused, or socially, the state says it and there's no choice, or I say it. Where else can you ground ethics if it's not these three? Generally speaking, Catholics take a view, the urethro dilemma. Heard of the urethro dilemma? Does God love a thing because it's good, or is a good thing good because God loves it? Most Catholics take the first rather than the second view of that. But if you get rid of natural law, then it's a second view if you're a theist, and God commands whatever, you know. Okay. So decline of belief in uncaused causes. So Newtonian mechanics doesn't actually say that God cannot intervene. It's often interpreted as if it does. And along with that, along with the fact that you get physical systems where you can predict where this is going to be in the future, there's a sense that's come into the Western mind that we don't have spontaneity in nature, we don't have voluntary action in nature, we don't have free will. It's not the laws of physics that produce this way of thinking in themselves, but they've encouraged certain habits in the way we think about the world that makes it difficult. And one consequence in the 18th century was the clockwork universe of deism, according to which God never intervenes in human affairs or suspends the natural laws, even though such laws do not, in themselves, preclude such intervention. And of course, there are other problems of induction. What justifies the straight line through a set of data points? I won't go into that now. And matter itself. You know, so it might seem that modern physics is intrinsically linked to a world that prioritizes matter and is often linked to materialism as a philosophy of the world. But the role of matter in physics, as it's developed from Newton, is more paradoxical than it seems. A Newtonian analyzes the orbit of a planet about the sun as mutually attracting point masses. The stuff, the matter, fades out of consideration. And nothing matters about matter except insofar as it contributes to resistance to acceleration. Everything measured, calculated, and predicted is actually formal. Future states are analytically reducible to present states, and time becomes like space. So materialism is paradoxically really formalism in the way we think about the world. I mean, matter doesn't seem to matter. It's not uncommon to find the claim that reality reduces to number, even though for Aristotle, number was a dependent reality. The mathematical universe of Max Tegmark, for example, despite the philosophical challenges that quantity is inherently ontologically dependent. Okay, so responding to the Hawking Lodinow challenge. So going back to that challenge I presented at the beginning, the grand design. Philosophy is dead. M-theory may offer answers to the question of creation, with multiple universes arising naturally out of nothing from physical law. But philosophers, yes, they're still around, back from the dead, would like to make a few claims and ask a few questions of their own. First, how can a law cause anything? You write down, you know, if there was a grand unified theory, write it down. Great, wait. Where's the universe? And laws aren't going to create anything. Laws are about things, are implicitly or explicitly about something that's more fundamental. And there's a lot of doubt about whether a law, in scientific terms, is causal at all. And Newton himself was sensitive to the philosophical limitation in his own work. On gravity, he stated he did not feign hypotheses about the cause of the changes described by his law of gravitation. And there are also lots of other limitations. The philosophical challenge of laws being adequate causes of being. So you can write down a law, but it doesn't cause a universe, doesn't destroy matter. But there's also the challenge of modes of being which are not captured by quantitative laws. Going back to the old Aristotelian model, substance and the nine different attributes or accidents of substance, quantity is only one of many. How many of those can be reduced to mathematics? I think one of the big failures of the artificial intelligence program, upon which billions of dollars has been spent, has been the challenge of reducing reality to mathematical representations. It sounds easy when you're talking about chessboards. When it comes to daily life, it's very hard to encapsulate to catch or reduce the richness of interactions of being in the world down to mathematics. Interesting book about this, still valid after more than 3 decades. Herbert Dreyfus, What Computers Still Can't Do. But when people say we've got a grand unified theory of everything, they're talking often about mathematical laws. But how can we capture all of reality which isn't expressible by mathematics? The challenge to the apparent irreducibility of observers to objects in quantum mechanics. I don't want to get too into this area because it is a matter of huge debate, and it's very hard to know how we can empirically decide between the different schools of thought how to interpret quantum mechanics. But I think most people would agree, who think about it deeply, that it's really odd. We get situations where apparently the act of observation seems to change physical systems in empirically verifiable ways. And there are different schools of how to get around that. Maybe they're hidden variables, but the space for hidden variables seems to be shrinking. Or there's a rather drastic option where all paths are taken at decision points, and we ourselves are in multiple states from each decision point of change in the universe. But that's rather drastic. Either way, we seem to have to violate our common sense view of reality. There's a challenge of light being more fundamental principle than space and time. It's a beautiful image of light being curved by a gravitational lensing of distant galaxies. And I think this has been subverted. This is something that Lee Smolin picks up in his book, The Challenge with Physics. You see, we write down physics today in relation of things changing in relation to space and time. But the essential insight of Einstein is that the thing that doesn't change is light, the speed of light in a vacuum in different reference frames. Space and time do change. So light is more fundamental than space and time, but how do we really capture that mathematically without freezing the insight and subverting it? A lot of modern physics, including the work on string theory, isn't properly linked in with relativity. And there's also everyday stuff. This, in fact, of those 3 things I mentioned, quantum mechanics and relativity, this one probably attracts the least attention, and yet it's in fact, the easiest to understand and to get some philosophical traction from. I mentioned about the two-body assumption. Most people don't know, at least I didn't know this when I studied physics, that Newton didn't solve the 3-body problem. And in fact, he tried to solve the Earth, Moon, Sun system, discovered he couldn't integrate it. His successors tried. They failed. They were able to invent certain ways around it, perturbation theory. There are all kinds of clever techniques for getting around this. But we can't integrate a 3-body system, not perfectly across a general range of cases. And since the invention of computers, we've discovered that some of these systems, when they're modeled, have end-directed action. And we give names to these things, strange attractors in chaotic systems. So you can actually start in a phase space, some state of the system represented by a point in the phase space, and it orbits in the phase space. We lose predictive power of exactly where the point will end up, but the point does end up in the vicinity of an ordered shape. Most famously, the Lorentz attractor. That's where it started, but there are many others discovered since then. Now, this is a state to which the system evolves, and it's not through dissipation of energy. It's not like a ball rolling to the bottom of of a gravity well. The systems move towards final states. And what's interesting is you can't reduce the final state to the other causes of the system, not mathematically. So two things come out of this that were apparently abolished by Newtonian science. One was the concept of a telos, an end, and the other is a concept of matter, because the only thing connecting the final state to the initial state is some principal continuity which is there when all the formal stuff is taken out. That's matter. So you get matter and end back in physics. So it's interesting, the last few centuries, we've been moving the mechanical view of the world, encroaching on biology and encroaching on human beings. And now we seem to be going the other way. We've got metaphysics inspired by biology, which is actually going the other way, even into quite simple mechanical systems. By the way, teleology doesn't mean automatically God did it. Because, in fact, people think that teleology is so close to theism that some people don't touch it for that reason, because they don't want faith. But actually, teleology in nature is part of nature. It doesn't automatically mean that it doesn't automatically take you to theism. Of course, I would tend to think it gets you there in the end. And of course, all kinds of phenomena these days which we recognize as being examples of, if you like, strange attractors or something a bit like that in chaotic systems. So deflating hubris. Got a few minutes, right. So going back to Stephen Hawking and Lodinow, the grand design. Is philosophy dead? Is role usurped by science? No. Can M theory or any theory answer questions of creation? No. Theories deal with whatever already is. And describe how, in modern science, how the quantitative aspects of certain kinds of phenomena change over time. Can even a single universe arise from physical law? No. Laws don't create anything in themselves. How should we explore the question of creation? Humility and wisdom. It's a lovely little admission at the end of Lee Smolin's book, that he wrote this book partly to avoid having to think. Because it's actually quite hard thinking, right? I mean, really thinking deeply. It's much easier to be in academia and manage processes and administration and teach this and that, but actually sitting down thinking hard in the same way that Einstein did when he thought, what would you like to ride on a beam of light? That's hard, because you have to really question the assumptions that there's so much formal thinking, our lazy thinking, that it's quite painful. There's a sacrifice involved. Humility and wisdom will take us further than mathematical theorizing alone. The mathematical theorizing is wonderful. We get that right. We're very, very good at that, right? But we need the other stuff as well. And we've got a bit of a hiatus, it seems, in certain sciences, because, in a sense, it's what we're missing. It's this other stuff. It's having some philosophical training, which I think would enrich the wonderful work we do in computing and mathematics. So very finally, as a little annex, sorry, I've gone on a bit. What does faith do, if anything, for cosmology? Well, I don't think that faith, obviously faith doesn't give us facts about the world we cannot find out by other means, but it does shape the way we think about the world. And we can see some evidence for how perception of the world changes with the eyes of faith. Although there are a few facts that are worth knowing about. So obviously you know who this gentleman is, don't you? Okay, and I hope you all know who this gentleman is. Who does know who this gentleman is? Who is it? Yes?
It's Lamette.
Thank you. Does anyone know Lamette? Some people do, some people don't? Okay, I've added some value. Good, there they are. And he is, of course, the father of the Big Bang Theory. But he had another job. What was his other job? He was a priest, okay? I mentioned this, even among such an esteemed audience, maybe some people who don't know that a priest invented the Big Bang Theory. Very few people know that it was banned in the Soviet Union for 30 years, pretty much. There was a meeting in 1948 in Leningrad where astronomers were urged to oppose the Big Bang Theory because they said it is promoting clericalism. I sometimes prepare posters for schools about these things because people just don't know this stuff, right? Okay. And mentioned also in cosmology, Angelo Secchi, the father of astrophysics. So it's just a bit of general knowledge. Okay. Faith forms understanding by philosophy and time. But what I wanted to show you was it also, if you like, shapes the way we look at the world. And this was the world, actually a view of happiness for human beings, as it was seen in 1432. This is one of my favourite pictures, the Van Eyck Adoration of the Mystic Lamb, completed in 1432. And you'll see here the idea of the saints gathered in glory around the Lamb of God, and nature perfected, nature ordered, nature beautiful. Now, in 1524, you can begin to see the saints are getting smaller, the landscape's getting bigger. These are transition pictures. And by 1569, the focus is on nature, and there's a little church in the background, but very small. By, of course, the late 19th century, early 19th century, you've got some of the most beautiful landscape painting. But notice what's not there. What would have been the great theme of most Western art between about 500 and 1500 AD, saints, sacraments, cross, salvation, all those sorts of things. All those are gone. The focus is on nature. By late 19th century, the perception of nature is becoming a bit strange. This is Van Gogh's Wheat Field with Crows, the road's going nowhere, the vertical dimension, the transcendent dimension is beginning to collapse. And by 1947, Jackson Pollock's Enchanted Forest. I don't want to make a value judgment. I just want to say one thing, right? Very careful, right? I don't want to make a value judgment. Well, just put it to you one thing. The faith, if you like, the faith that shaped the grand narrative of our culture, our society, and our minds also shapes the way we perceive the world. And I speculate that one way this happens is through what you might call right hemisphere cognition, or the thing that's metaphorically associated with right hemisphere cognition. But we have some kind of ability to conceive the world, not just in terms of point facts, but also the grand narrative within which the facts are unified. And without that, we get the details right, but we lose the big picture, and we don't get the bits to fit together properly anymore. That's why I think it's so important, particularly those who are teachers in religious studies, education, to know the stories, to know the parables. The story of Exodus in the Old Testament, by the way, is also the story of a soul. I don't know if you know that. Original sin, baptism, 40 years in the wilderness, this life, Eucharist from heaven, crossing the River Jordan into the Promised Land. You see, it's actually the story of a soul. So the Old Testament, a lot of the Old Testament is the New Testament for the right brain hemisphere. Okay. God's smart, you see. Okay. And faith falls understanding by hope. You know, it doesn't all end in chaos, dust, and death. Okay. So just a final. And just to give you two brief narratives here. This was Simon Blackburn, Professor Simon Blackburn from Cambridge, reviewing one of John Polkingham's books. And he's saying, you know, nature shows us no particular favors. We're not that nice to each other. We occupy an infinitesimally small fraction of space and time. We evolve through cosmic accidents. There's no order, there's no purpose, no nothing. Right? And this was Clement I of the Corinthians. This is the beginning of the first Christian century. And he's talking about the harmony of the cosmos. And I've sort of wondered which one, over the long term, will be most fruitful for doing cosmology. I thought early Christians had other things to worry about, but they're already thinking about cosmology in 96 AD. Isn't that amazing? Okay. So the worldview bequeathed by Galileo, Newton, and Descartes still shaped, to a large extent, our approach to science and cosmology. As a result of new developments, the proper scope of the philosophical principles inspired by early modern science are more clearly seen. I think we need humility, wisdom, the sacrifice to think hard, which will take us further than mathematical theorizing alone. And without drawing a strict cause and effect relation, history suggests a perception of the world shaped by certain kinds of faith, either in a first-order sense, personal faith, or second-order sense by, if you like, shaping the culture, has proved fruitful, including fruitful for science. Thank you very much.